Hey guys, so what we're going to be doing today, I'm just going to go over the answers to the 2, 5 through 6 quizzes review of implicit differentiation and inverse derivatives. So let's go ahead and start with this first problem here. It says that if f of x is equal to cosine of x and if f inverse of radical 2 over 2 is equal to pi over 4, find the derivative of f inverse. Okay, well, they kind of gave us a little Easter egg here. They kind of gave us something important, and it was this point right here. If f inverse of radical 2 over 2 is equal to pi over 4, then we can probably say that f of pi over 4 is equal to radical 2 over 2. And that's just a property of inverses. Inverses switch input with output, which is probably good to know. All right, so we want to know what's the derivative at at radical 2 over 2. So here's what we're going to do. To find an inverse, the formula for the derivative of inverse is written as such. F inverse of x prime, the derivative of an inverse, is equal to 1 over f prime of f inverse of x. So basically, if we know this formula, we're kind of good to go for this. So let's go ahead and plug in what we know. We want to evaluate it specifically at radical 2 over 2, and we know that f of x is cosine of x. So let's go ahead and plug in what we know. So f inverse of radical 2 over 2 prime is going to be equal to 1 over f prime of f inverse of radical 2 over 2. All right, well, they literally told us what f inverse of radical 2 over 2 is. They said that at the beginning. And the inverse of radical 2 over 2, did they tell us that? Yeah, they told us it right here. The inverse, f inverse of radical 2 over 2 is pi over 4. So we're literally going to replace that with pi over 4. So really all we need to do now is we need to figure out what is f prime of pi over 4. So I want to know what's f prime of pi over 4 and what's 1 all over that. Well, the best way to find f prime of pi over 4 is to find f prime. To find f prime, let's take the derivative of f. F prime here is going to be the derivative of cosine, which is negative sine. And so really what I want to find here is I want to know what's 1 over sine of pi over 4. And yes, you're going to have to know your unit circle for this one. Sine of pi over 4 is radical 2 over 2. So this is 1 over radical 2 over 2. If you keep it, switch it, flip it, you're going to get 2 over radical 2, which we probably need to simplify. So right now our answer is 2 over radical 2. Let's rationalize because if we don't rationalize, we might not see the answer in the proper form. So if we rationalize, we're going to get 2 radical 2 over 2, which these 2's cancel. And so what we're left with is radical 2. And so the answer here is D, radical 2. All right, All right, let's go on to the next one. Next one, same kind of problem. We know f of x, we know f inverse of x, and it says find the derivative of f inverse. Okay, so hopefully this should go a little bit faster now that we're getting the swing of it. We're going to find the derivative of f inverse of x, and specifically we're going to evaluate it at 20. Remember that the derivative of an inverse is equal to 1 over f prime of f inverse of x. Okay, well, first thing I want to do is evaluate it specifically at x is equal to 20. So if I replace x with 20 here, we know that f inverse of 20 is 25. That's given. So let's go ahead and replace this. I know that I want to find 1 over f prime of, well, f inverse of 20 is 25. So I want to know 1 over f prime of 25. Best way to find f prime at this point is to take the derivative of f. To do that, I'm going to rewrite f such that it's easier to take a derivative. We're going to say f of x is equal to 4 times x to the 1/2. If I find f prime of x is going to be 1/2 times 4x to the negative 1/2. So I'm going to power reduce there. So if I simplify this a little bit, I could get f prime of x is equal to 2 square, I guess we'll just leave it, 2x to the negative 1/2. So all we need to do is replace. Okay, so what I want to know is what's f prime of 25? Well, let's find that. F prime of 25. That's going to be 2 times 25 raised to the negative 1/2. Okay, 1/2 really just means square root, and negative means 1 over. So this is really asking, what's 2 over the square root of 25, which is 2 over 5. So the answer here is going to be 1 over 2 over 5, which is f prime of 25. This is the same number here. And then we're going to keep it, switch it, flip it. So the answer here is going to be 5 over 2. And that is letter A. All right, let's move on to the next question. So next question here. F of x is equal to 3x plus 10. Find the derivative of the inverse at x is equal to 2. Okay, well, this one's going to be a little harder to find because this time they didn't give us a point. So we're going to have to find the point ourselves. So because this is a linear function, it actually would be really easy for us to just straight up find the inverse here. So I'm going to find the inverse of f of x. To find the inverse, I'm going to write it as y is equal to 3x plus 10. And I'm going to switch x and y and solve for y. So if I switch x and y here and solve for y, I'm going to get x minus 10 all over 3 is equal to y, which means that the inverse, f inverse of x, is equal to x minus 3, so x minus 10 over 3. So we could use the formula at this point, or we could just literally take the derivative. It's really up to you. I think it's going to be easier just to take the derivative. So if I want to find the derivative of this whole thing, let's rewrite it so that it's a little easier to take. If everything's divided by 3, I could actually rewrite this as 1/3 x minus 10 over 3 is equal to y, and we're trying to find the inverse. We're trying to find the derivative of this. And actually, just to even be more clear here, we're going to say it's not equal to y. We'll say it's equal to f inverse of x. That way we can see we're taking the derivative of the inverse. So we take the derivative here. 1/3, the derivative of 1/3 x is 1/3. Derivative of 10 over 3 is 0. And the derivative of f inverse of x, I'm just going to write as f inverse of x prime. And so we can see it doesn't even matter what we plug in at this point. The derivative of the inverse here is always going to be 1/3. And so the answer here is B. All right, next one. If f of x is equal to x cubed over 27, we're going to use the same method. In fact, this method of finding the inverse and taking the derivative is a totally valid method. In fact, it's probably easier to do when the inverse is possible to take. So if we take a look at the first couple examples, we couldn't take the inverse very easily. I guess we could have. So it's really up to you. But something like f of x is equal to cosine of x, taking the inverse would have been more challenging in that situation. So it's usually your best bet to use the formula, but if you can take the inverse, take it. So I'm going to find f inverse. To find f inverse, I'm going to set this equal to y. I'm going to switch x and y and solve for solve for y. So x is equal to x cubed over 27, which means we're going to get 27x is equal to y cubed. If I take the cube root, I'm going to get the cube root of 27x is equal to y. So just remember that when you take the root of an odd power, you don't need to have plus or minus there because you can have a negative inside of an odd power. All right, so from here, if this is the inverse, this is f inverse of x, I'm going to say that this derivative here is not going to be that hard to take. So I'm not even going to use the formula. I'm just going to take the derivative. To take this derivative, I'm going to rewrite it a little bit different. Well, the cube root of 27, 3, 9, 27. Cube root of 27 is 3, so I'm going to simplify this a little bit. This is going to be 3x to the 1/3 is equal to f inverse of x. And all we're going to do is take the derivative. So if I take the derivative here, I'm going to get 1/3 times 3x to the negative 2/3 is equal to f inverse of x prime, the derivative of the inverse. If I simplify this, I'm just going to get x is equal to, x is negative 2/3 x raised to the negative 2/3 is equal to the derivative of the inverse function. All they want to know now is evaluate it at 1. Okay, well, that's super easy. 1 raised to any power is going to be 1. And so the answer here is 1A. All right, next question. It says find the derivative given the following values. Okay, so it says find f inverse of x prime at a. So this is really saying find f inverse of a prime. So find the derivative of the inverse at a. Okay, so for this one, there's a lot of different options that we could take here. We could literally find the inverse, or we could use the formula. The inverse looks pretty easy to take, so I'm going to take it. The inverse of f of x, well, if I write it as y is equal to x plus 2, if I switch x and y, I'm going to get x is equal to y plus 2, so its inverse is going to be x minus 2, which is pretty easy. So I know that the inverse function is equal to x minus 2. So they want to know what's the derivative of this. Well, to find the derivative of this, that's going to be super duper easy. The derivative of x minus 2 is going to be 1 minus 0 is equal to the inverse of x prime. So we can see here it doesn't matter what I plug in, the answer is always going to be 1 here, and so the answer here is C. F inverse of A prime is always going to be 1. The derivative of the inverse will always be 1. All right, next one, similar situation. For this one, you can once again, I would say for this one, let's use the formula just because this is going to be hard to put in explicit mode. Reason being is you're going to have to take the plus or minus square root, which is going to make things a little bit harder. So I'm actually going to use the formula this time. I know that F inverse of X prime is equal to 1 over F prime of F inverse of X. Okay, so what I want to do first is I want to evaluate that at A. So I want to figure out what's F inverse of A, and then kind of go on from there. Thankfully for this, I think they told us what A is. Thank goodness. They said A is equal to negative 18. So what I want to know is if I want to find the inverse, I need to kind of flip X and Y. So inverse function flips X and Y. So right now, I know that F of negative 18, let's go ahead and plug it in and see what F of negative 18 is real quick. Okay, with a quick calculator check, I think it's going to be negative 1618. So using what I know about inverses, this would mean that F inverse of negative 1618 is equal to negative 18. So unfortunately, that's not super helpful for me because what I want to know is what's F inverse of 18. So if I rewrite this here, what I'm really looking for is this. I want to know what's F inverse of 18 prime, which means I need to know 1 over F prime of F inverse of 18. So what I'm really looking for is what is F inverse of negative 18? Negative. To find F inverse of negative 18, I basically am switching input with output. So what this is saying is when I have an output of negative 18, what's my X value? So a good way to find this is actually set the whole function equal to negative 18. Instead of saying F of X is equal to, I'm going to say negative 18 is equal to negative 5x squared plus 2. And if I go ahead and try to solve this here, I'm going to get negative 20 is equal to negative 5x squared. Ooh, this is going to turn out great for us. Divide by 5 on both sides, and we're going to get 4 is equal to x squared. Take the square root, and that means that we're going to get 2. So notice here that there's a little bit of a statement because it should be plus or minus square root in theory. So I'm actually going to do that, plus or minus square root. So we're going to take the plus or minus square root. But notice here it says x is greater than 0, which means we only need to take the positive square root. So we know here that x must be equal to 2. Okay, well, if x is equal to 2 when the function is set equal to 18, that means that f inverse of negative 18 must be 2. So we have our point that we need. We have the point that we need. So we're going to plug this point in. F inverse of negative 18 is going to be negative 2. So let's rewrite this. This is going to be equal to 1 over F inverse, sorry, not F inverse, F prime of, well, F inverse of negative 18 is 2. So all we need to do now is find the derivative evaluated at 2. So we need to find the derivative ourselves. To find the derivative, it's a really easy derivative to take. I'm going to take the derivative of negative 5x squared plus 2. So to do that, I'm going to get negative 10x plus 0. And I want to specifically find what's f prime of 2. So if I plug 2 in, I'm going to get negative 10 times 2, which is negative 20. So I'm going to plug negative 20 in. So the answer here is going to be 1 over negative 20, which is on our answer sheet, thank goodness, as answer letter A. Okay, let's keep moving. We're about halfway through. All right, next one. It says find the derivative at the given value of A. Okay, so this one right here, you can use either method. You could either use the definition of derivative of an inverse, or we could find the inverse. For this one, I'm going to go ahead and use the definition again, since we haven't got to use it too much. All right, so the definition of a derivative of an inverse is this: f inverse of x prime is equal to 1 over f prime of f inverse of x. Specifically, we want to find it when a is equal to 2. So we want to plug in a for x. So in this case, we're trying to evaluate this when x is equal to 2. Okay, well, what I need to do is I need to find f inverse of 2. Okay, well, if I'm looking for f inverse of 2, that's really saying when is the output equal to 2? To find that, I'm going to take the whole function and set it equal to 2. 2 is equal to 3x cubed minus 1. If I add 1 to both sides, I'll get 3 is equal to 3x cubed, divide by 3, and we get 1 is equal to x cubed. And take the cube root, we get 1 is equal to x. So remember, the cube root doesn't have a plus or minus. Okay, so that means that f inverse of 2 is equal to 1. So let's go ahead and plug that in. This is going to be 1 over f prime of 1. So all we need to do next is find the derivative of f of x. To find the derivative, we just need to take a really easy derivative. This is going to be f prime of x is equal to 9x squared plus 0. So f prime of 1 must be 9 times 1 squared, which is 9. And so the answer here is going to be 1 over the derivative at 1, which is 9. So the answer here is 1/9. All right, next one. All right, so now we're getting finally into implicit differentiation again, which is what we're also trying to review today. It says find dy dx by implicit differentiation. Notice here how the denominator is x, which means we're taking the derivative with respect to x. So let's go ahead and start this. The derivative of x cubed is super easy. That's 3x squared. And technically, you could say I took the derivative of x with respect to x, which is dx, but that's going to cancel out, so we're not going to write that. Plus, well, the derivative of y is still pretty easy. That's 3y squared, but I took the derivative of y with respect to x, so I'm going to say dy dx. Lastly, the derivative of 36 is 0, and so all they want you to do is solve for dy dx. I'm going to subtract 3x squared on both sides. And what we're going to get after we divide, we're going to get 3x squared divided by 3y squared. You guys have probably seen this problem a lot. It's probably pretty familiar. And dy dx is going to be equal to x squared over y squared. Okay? Which I think is, did I miss a negative somewhere? Yep, there we go. Which is this answer right here. All right, next one, find dy dx again. This one's great because we're going to have to use product rule. So we have x times y, so take note of the multiplication there, plus y squared is equal to 2. Once again, we're taking the derivative with respect to x because it says find dy dx. So I'm going to go ahead and take the derivative of the first piece. This is product rule here. Anytime we see multiplication, we need to use product rule. Okay, I'm going to say derivative of the first times the second plus the first times the derivative of the second. Well, the derivative of y is 1, but I took it with respect to x. So I'm going to say 1 dy dx, or just dy dx. Plus the derivative of y squared, that's not product rule, that's just going to be 2y dy dx. And the derivative of 2 is 0. So all we need to do here is solve for dy dx. I'm going to move anything that's not dy dx to the other side. So I have x dy dx plus 2y dy dx is equal to negative y. I'm going to factor a dy dx out of the left side and get x plus 2y on the inside. And then I'm just going to divide. So dy dx has got to be equal to negative y all over x plus 2y. And that's the solution here, which is this one right here. Okay, almost done. We've got 3 more questions, I hope, left. All right, number 10, it says find dy dx at the given point. Okay, well, the first thing we're going to do, let's just focus on finding dy dx first. So to find dy dx, we're going to go through and take the derivative with respect to x. 3x cubed's derivative is 9x squared, dx dx, so don't need to do anything there. Plus, this right here is product rule, so we're going to have to treat it as such. We're going to say derivative of the first. If you want, you can pull 4 out, or I've seen some people just treat 4x as one piece, so I'm going to do that this time. I'm going to say derivative of the first. Okay, so that's 4x, which is 4. Copy paste the second, plus the first, which is 4x, times the derivative of the second, which is dy dx. The derivative of y is 1 dy dx, is equal to 0. So all we need to do here is solve for dy dx. So I'm going to move anything that's not dy dx to the other side. So I get 4x dy dx is equal to negative 9x squared minus 4y. And we're going to divide everything by 4x to get dy dx by itself. Well, that's not the answer quite yet because we want to know what's dy dx specifically evaluated at negative 1, 1. Negative 1. To do that, I'm just going to plug negative 1 in for x and y. So this is going to be negative 9 times negative 1 squared minus 4 times negative 1 all over 4 times negative 1. Negative 9 times negative 1 is going to stay negative 9. Double negative here is going to turn into positive, and that's going to be over negative 4. So if we simplify this here, we're going to get 5 over negative 5 over negative 4, which is positive 5 over 4. So this right here is the solution. Okay, next question. Find dy dx of this function. All you got to do, once again, is use implicit. This one's pretty easy because there's no product rule. Okay, so what we're going to get is 4x minus 3y dy dx is equal to 0. Move the 4 over and divide. You're going to get 3y dy dx. So you're going to get dy dx is equal to 4x over 3y. So 4x over, I take that back. I think I need to change something. Here we go. This turns into a 6. Sorry about that. That's 6. 3 times 2. So 4x over 6y is going to be 2x over 3y. So 2x over 3y is the answer here. All right, let's keep going. Almost there. All right, so it says find dy dx for this. All right, this is a great example because this is an example of chain rule and implicit differentiation. Oh, not really, actually. It's just chain rule. Anyway, let's go and take the derivative. Y is already solved for us. The derivative of y with respect to x is dy dx. So it's already solved. That's awesome. Okay, to take the derivative of x squared plus 1 cubed, we're going to have to use chain rule. We're going to say derivative of the outside, which is the cubic function, copy paste the inside, times the derivative of the inside. So we're just going to pick the one that has the answer, which is, well, let's simplify it. 6x times x squared plus 1 squared. So let's see where that one's at. So the answer is right here. Okay, very last question here. It says evaluate the derivative at point P. Okay, so remember here, this is x times y is equal to 36. We're taking the derivative. It's assumed we're taking the derivative with respect to x. It should probably say it, but oh well. So let's take this derivative here. We're going to take derivative of the first, which is 1, copy paste the second, plus the first times the derivative of the second, and derivative of 36 is 0. So what we're going to get if we solve for dy dx is that dy dx is equal to negative y over x, which we've kind of seen this before. All they want to do is say what happens at point 12, comma 3. And it looks like a point, honestly, but I think it's a comma. So what we're going to get here, we're just going to plug in 12 for x, and we're going to plug in 3 for y. And so what we're going to get is negative 1/4. And so negative 1/4 is the answer here. Okay, I know that was only 13 questions, but whew, that was a lot. So if you guys have any questions, once again, feel free to send me a message. And I hope that this is really helping you guys hone in this skill. All right, have an awesome day. See ya.